Good to go. Okay. Andrew Markell here, and I'm with Underhood Service, the Director of Technical Content for the magazine. And today we've got a great live cast sponsored by the folks at Summit Racing, and we're talking about OBD1. In other words, anything pretty much before 1982, I want to say, before there was a computer on the car, versus how those same diagnostic strategies work for an OBD2 car that could have rolled off the assembly line today. And with me, I've got Justin Wiedemann. He is with Summit Racing, and what's your title there now?
So I'm Summit Racing's video host and technical advisor. You know, I help with a lot of the YouTube content, and I'm their, on-camera wrench. So, bringing great content to the people of YouTube.
And we enlisted your help, and we were working on a, 76 El Camino, small block, quadrajet. Let's roll the B-roll of that car right now to show what we were working on. And what did we install on that vehicle?
So we installed the Summit distributor, coil, and ignition control module. So it's a really great kit. It kind of replaces. It's a viable replacement for, like I said, your OBD1 cars. So a lot of those parts are them cars are getting older and the distributors are worn out and stuff like that. So it's a great replacement for to bring your car essentially into the 21st century.
And I think it was great what we were doing with the that vehicle, because it wasn't just installing the components, it was also looking at what was wrong with the car in the first place and looking at the overall condition and what was going on underneath the hood and inside the cylinder. I think that was very important with that. And it was kind of an interesting vehicle because you did more or less more of the work underneath the hood, and I was your tool runner. And we had a great conversation going with other technical people in the building in regards to what was going on, and lots of curiosity about that El Camino.
Yeah, that car, that thing's a sweetheart of a car. It takes me back to a simpler time, if you will. You don't see cars like that, driving around on the roads nowadays. A lot of, they're either in a scrapyard or they're sitting, in someone's garage somewhere. So with that thing, it was kind of nice to just, get your hands on it. It was mostly all original. Like I said, it had an original distributor in it. The plugs probably haven't been changed in a considerable amount of time. And it was cool just to do some, diagnostic on it and see what the whole, how the whole car was. So, we started with the whole deal with just some diagnostic work to make sure the thing was in good running condition before we just went throwing parts at it, because you don't want to bolt a bunch of new shiny parts on a car that's, it's got, a sticky valve, or, it's weak, or the thing doesn't run real well. Like, you want to, making a car run well and drive down the road is a lot like building a sandwich, and you need to start with a good foundation before you do anything else. So that's where we started with. We started the whole deal with was making sure it was in good running condition before we went ripping it apart and, made it not run again.
Let's run a little bit of the inspection video, actually, or we're doing the initial testing. And, here's the spark plug being pulled. Could you pause it right there? So you really look at that plug, that's an awful lot of carbon.
Yeah, that plug has definitely seen better days. It looks like it's been in there for a considerable amount of time, and it's got a bunch of gap. Like, if you look at the electrode on the end, it's pretty burned up. So regardless if we were throwing new parts at this thing or not, it at least needed a tune-up. So, but pulling the plug, there's not a bunch of unburnt fuel on it. The strap doesn't look like it has a good burn mark on the strap. It's nothing crazy, just an old, dated, worn out plug.
Let's go a little bit further into this clip here. So this is where we were installing the compression gauge.
Yeah, so we wanted to check the compression on the car first to make sure it didn't have, a weak hole or anything like that. So we went through, checked it all. It tested really, it had a good, nice compression number. I was really impressed for, if it is a small, you don't know with some of these stock small blocks, since they've been in cars so long, if they've been,
Could you pause it 1 sec here for the video? Thanks.
If they've been pulled apart, you don't, with cars like this, it's an unknown thing. So it could have been, rebuilt and remanned at one time in its life, or it could just be a low-hour small block. So the thing had great compression, and that was a really, really promising for us. We also went ahead and did a leak down test on it to make sure, the thing didn't have a sticky intake valve or anything like that. So if you look at the gauge there, I mean, we got a nice, almost 160-pound number from a compression check. So that lets you know it's in good health.
Let's go back to that compression gauge one more time. Right there, that was pretty good for an engine that's, how old is that car? Almost like 45 years old now?
Yeah, it's it's definitely got some time, and it's seen some stuff. So to get a good number out of an engine like that, like I said, it's in good running health.
As far as the rest of the cylinders were all within probably 5 pounds?
Yeah, it tested really close. So like it didn't have like a down hole where it was like one would test like 130. Like you get about around that 130, 140 number. There's some issues there. She's seen better days and she's a little worn out.
And you mentioned we did that leak down check on the vehicle using the leak down gauge. And that was pretty interesting. We actually managed to get enough pressure inside that cylinder to actually bump it over. Let's play a little bit more of that clip. So we looked at the timing next on the thing.
Yeah, and if you look at that picture there with the timing, you can actually see that the balancer is spun on the car, and you'll notice, and that's something you need to account for with some of these older small blocks is, it's a steel hub with a rubber, it has a rubber dampener around it, and then another steel hub on the outside of that. So over time, what happens is that outside balancer will actually move. So, your timing mark might not be true to what it actually is marked on the balancer. So it's very important that you check that. And if it is off and you don't want to replace the balancer at a time, there's a couple things you can do. You can either mark it with a paint marker, or Summit Racing sells a really cool product, and it's actually a roll of timing tape. So you can go ahead, set your car at top dead center, see where your actual timing mark is, and then install the timing tape so you know for sure where your mark is. So you're not going off what it's marked on the balancer, because you don't know, and you always need to check, because that's the last thing you want to do is go ahead and put too much timing in the thing and let the magic smoke out of it.
And another thing we kind of noticed too was the distributor in there had quite a bit of play in the shaft.
Yeah, the distributor gear was definitely wore on that thing, and that's kind of the way a small block distributor runs is it runs off the cam. So it has a brass, steel, or melanized gear on the bottom of the distributor, and over time that gear wears, and you get a little slop in it, and that's good for 3 to 5 degrees of timing. And eventually what happens is that gear, if you don't replace it and don't check it over time, the gears do give up, they splinter apart, and all that stuff ends up in your oil pump, and that's never fun. So that's a good thing to check when you're pulling your distributor out of your car, or that's just a general, it's something that needs to be looked at from time to time. Now, I'm not saying every 20,000 miles you should yank it out, but at 50,000 miles after you put a small block together, you should check it. That's something to think about, because a couple degrees in timing variance can have an adverse effect on stuff.
And then with our underhood service team, and also our readers out there who are doing a lot of diagnostics on a lot of modern vehicles, I think that OBD 0 type philosophy actually applies to a lot of that, because you said 3 to 5 degrees of timing change. I mean, that's on a modern vehicle, you're setting a misfire code typically. And, just making sure that, that cylinder's operating in the same, the rest of them, I mean, a misfire code is more or less, it's the crankshaft position sensor measuring either a difference in when the cylinder fires, if it's late, or not even there at all, or even too advanced. That's what will set a misfire. And 3 to 5 degrees on an OBD2 car, if it detects that, that's probably going to be a misfire.
Oh yeah, and that's what not only from a crank sensor position, but even from like a note, on some of the GM stuff where you have knock sensors. That's with a timing variance like that, you're going to get like I said, it'll give you a knock sensor code and do some, like I said, other odd things. That's the thing is with modern OBD2 vehicles, there's a lot of, everything it has to run like a sewing machine, or else, the computer picks it up and it sees an issue. Not like our El Camino, where if you, fuel, air, spark, and it'll run.
Yeah, that's the thing I think with a lot of modern cars, even when you take it one step further, direct fuel injection. You have your finger on that one piece of the distributor, the rotor itself, and you see a little bit of that variance in the system to where it can get away with that. It doesn't have as much compression, it runs a little bit richer, the carb is adding more fuel, to where if it's a direct injection car, it's very, very precise in terms of how much fuel it's putting in the cylinder. And that thing between lean or too rich or just right within stoic is just like, it's so narrow compared to an older vehicle like our El Camino.
Yeah, there's definitely it's a much narrower window for something to run correctly, like I said, a modern direct injected in an automobile. Where, like I said, some even for emissions purposes and stuff like that, like it has multi-injector burst, and there's a lot more going on there. It's not a controlled fuel leak like the carburetor on our El Camino.
You think about that when the secondaries have to come in, when the primaries open, the fuel, the rods, the float levels, and everything else. I mean, it's reacting to what the engine and the throttle plate's doing as far as, creating that vacuum to suck the fuel through.
Yeah, and we've all drove, a carbureted vehicle that's been, it hasn't run the best, but it runs down the road, and you're driving it might have a little exhaust leak. You can tell it's rich, and your eyes are burning in the cab. Like, you don't get that with some of this modern stuff. And like I said, it's the modern automobile is, it's designed to run optimally all the time. Not, it's not a set it and forget it thing like a carburetor where where you're adjusting the timing manually, you're checking valves, everybody's drove something with a sticky quadrajet, and that's it runs, but it runs poorly.
And you even take the variances on top of that. The timing chain on the front of some of those engines, that can change the ignition timing. It can also change the valve timing, and that could cause a lot of issues with the vehicle itself. And that one seemed to have not too much play in the timing chain. I know we didn't really look at it too much, but we really couldn't detect any play in it.
Yeah, no, like I said, we just did kind of a general, check of health on that small block, and the thing seemed, like I said, it seemed tight. It hadn't seen, many bad days or some unemployable kid just beating the snot out of it. Like it has some life in it if it's treated well. And the car, like I said, seems really well taken care of, and so, but doing the install that we did, like that's going to do nothing but improve the drivability of that thing.
So let's play that clip a little bit more from where we were in it. So there's that play in the distributor. Wow.
Yeah, and that actually wasn't even a factory unit. That distributor had been replaced at one time before. That was an old Mallory piece, which is really, those are hard to come, that's few and far between stuff nowadays. So that distributor, those things are nice because, not necessarily you can buy the rebuild kit anymore, but if there's someone that's, a talented machinist or a restorer, like I said, someone looking for period parts, that thing can be fixed up and, made into a nice piece again. Like I said, it had some play and it had seen better days, but, it was time to be replaced.
So let's look at some of the clips from installing that ignition box. And we did a new coil, and you did the box too?
Yeah, so we did a new coil,
the mounting video.
A new Summit control box, which is like a multi-spark unit. So that not only has like an RPM adjustment and some other stuff, but like I said, it's a multi-spark box. So instead of having one big blue spark when the distributor works and it comes through and releases, it's a bunch of small, nice little sparks, and that's better for fuel burn, and it's going to, like I said, let the thing run a lot better. So we ended up mounting the ignition box to the fender well because under that car there is some room, but that thing's kind of bulky and you don't have a whole lot of places to do it. So I drilled 4 holes in the fender and mounted the ignition box, and it came out nice. It's somewhere where it's not going to see a whole bunch of vibration. It's actually got those rubber feet under it so the thing doesn't touch the fender. So it's a really easy install. Anybody with a little bit of time and a little bit of knowledge, anybody can install one of those ignition kits on your small block.
That one has a rev limiter on it?
Yeah, it has a soft rev limiter on it. So like a stock small block, we set it somewhere, I believe it was around like 56 or 5700. You're not going to see much more than that. We had to look at it like it's got stock, it's stock compression, it's got stock valve springs. It could have 45-year-old valve springs in that you don't know. And revving it any higher than 56, 5700 RPMs is not making any more power. You're just wearing the thing out and beating the snot out of it, and then it ain't good for it.
I followed Eric Garba. He is the owner of that El Camino, and he is one of the editors with Tech Shop Magazine, and also one of our content producers in-house. And I had the opportunity to follow in back of him when we were going down the freeway I-77, and I think it was early January before that really bad snowstorm hit, and it ran great. I mean, I got to give it to it. No bad smells from the back, no rotten egg smell, as they used to say, from some of those vehicles, especially the 76s, who had just the first inklings of emissions on there with EGR valves.
Yeah, that first, those mid-70s car, that is, what we always refer to as the beginning of the smog era. So, you were getting catalytic converters and all that stuff, that was the first emissions equipment, and they really choked down on the whole performance aspects of cars. Like, you think 20 years before that, or not 20, 10 years before that, you could buy something that was rated from the factory at 300 horsepower, and it was making a whole lot more ponies. Like, to go from, your 69 Camaro with a DZ302 to an El Camino with a small block that's a big difference.
Okay, we're going to play a game here. I think this is an interesting game. We were talking about this before we walked into the studio. What is the difference between these two coils, and just on a fundamental level? There's really not that much different, secondary and primary.
Yeah, they're basically, the science of how it works is all the same. It's just crazy to think, in the blue coil you have there, it has it's an oil-filled, regular coil, and it has a large secondary and primary winding in it, and then they manage to shove all that in to the coil pack, and then that goes directly on the spark plug. So, that's a much more contained unit, but the little guy puts out a whole lot more than the coil does.
Yeah, I mean, secondary, primary, you can do the same ignition test with these two. I mean, you could look at the current flow coming in and out on the primary. You could look at the secondary waveform from either one. A little bit different from this one. It's more of a parade, if you want to call it that, because it's doing 8 cylinders instead of just one. And fundamentally, if you can master the basic electrical of this, you've also got this on coil over plug, where there may be, 4, 6, or 8 of these on some modern engines. I think that's part of the, understanding, the basics of an OBD0, like our El Camino, and basically applying that diagnostic know-how and what's going on in terms of, was it misfiring? No, not too bad. We knew mechanically what was going on with that engine. So we knew that, okay, we had good compression, the valves were good, all the leak down was good on it. And we looked at a lot of the timing itself on the engine to make sure that it was good, and we even realized that, hey, the balancer was a little bit off. So, yeah, OBD0, OBD2, but essentially it's the same thing, creating spark inside a cylinder.
Yeah, it's just been applied, over the years. That's just how automotive technology has progressed, and it's been, they've learned that it's a lot more efficient to, you don't have a spark plug wire where you're creating resistance and you're losing this power over distance. Or, with the OBD20 in the coil, you're going from a coil all the way through a wire to the distributor, through the distributor to another wire to a plug, versus, you've shortened the deal to a coil on a plug, and it's a lot more direct.
Even if you take something like this, which may be a multimeter that has several ignition functions on it, or even something like this that, your grandfather or father might have had to work on ignition systems, compared to this, if you're looking at the ignition timing on this, or you're looking for misfire codes using this, you're essentially using these tools, but in a different pathway. And it's still critical, no matter if you are using one of these two tools down here or something like this, as long as you understand what's going on behind the scenes. When you see a data pin on here for the amount of spark advance versus here, or even looking at something like dwell, if you're able to understand those basic concepts on the primary and secondary ignition, it makes using this tool actually a little bit easier, I think.
Yeah, understanding the concept of how some of this stuff works is just as important as being able to use the tool. Because there'll be times as a tech where you might not be able to, you can plug it into the scanner and you're not going to get the direct answer you need. And some of the original diagnostic, methods that we're all taught when we're becoming mechanics is very important. And I believe that's important for, you know, techs of tomorrow to realize that, you know, sometimes you have to go back to the basics. And, you know, using a, you know, oscilloscope or something like that is not, you know, not out of the realm. It might not get you, it can get you the direct answer you need that you can't get through the scanner.
So we have a clip on there that says waveform. Let's pull that up. And this was installed, taking this waveform after the ignition box was installed. I think it's a waveform on the video packages. And usually that involves me connecting the sensor, or the inductive probe, they call it, I think, onto the main coil lead on here. And it produced a very interesting waveform. So here we are doing the compression again, but actually I think it's the one that says waveform. So, but waveforms for ignition have been around for, God, I want to say since the 30s or 40s.
Yeah, you know, it started out, it kind of, you know, the original machines look like a game of Pong, where it's a black screen with a white line across, and it's kind of, you know, it's blipping essentially.
Yeah, they called that the parade on some of those. And it, you know, I got to be honest, for technicians back in those days, it made them seem like it was real science, which it was. But it was essentially the technician looking at the secondary waveform and looking at all 8 cylinders on one, you know, a tube type screen to see what the parade was doing by just going up and down. And with that, you can do the same thing with a scope and some of the scan tools, and looking at also a small secondary of the waveform itself.
Yeah, and it's very cool to look at how, you know, how a coil is charging and discharging on, like, say, on a scanner, like, say, a picoscope or something like that. There's tons of, you know, it's nice with how the modern scanner has worked is, you know, you have all these functions in one tool versus, you know, 20, 30 years ago, you had there was a whole electrical diagnostic cart in a shop, and there'd be all these, you know, the scanner has made it available to where you only have to own one tool, and it's really affordable. You know, now there's some that are more fancier, so if you're a home tech, it doesn't really make sense. But, you know, if you're working in a shop every day, and, you know, owning a good scanner that's a valuable tool to have. And they've packed a lot of these different tools and features into one deal, and that makes it really nice versus having, you know, an entire roll cart of just electrical diagnostic tools.
You know, there's borescopes that can be used on these. There's a way to look at, you know, inside the cylinder, take a picture, and then even send it to the customer so they can see what's wrong with their engine, or a carbon buildup, which is becoming more and more of an issue. I never would have thought, you know, here it is 2020 and carbon is still an issue inside engines.
Oh yeah, and you see some real issues nowadays, even with, like I said, with modern, you know, modern fuel injection and direct injected cars, buildup is still a real thing. So you'd be surprised. It's not like pulling a LP gas motor is a really good example, because in LP gas applications, it burns really, really clean. So you pull a lot of those motors apart, and LP gas stuff is just, it's beautiful on the inside. There's nothing, you know, it looks like a brand new parts put together a lot of times versus, you know, then you pull like our small block apart, like out of our El Camino, and that thing will be dirty.
Yeah, you think about how much fuel has to be put into the cylinder to get that thing started, and just it was a guesstimate. I mean, they didn't, you know, it's not actuated by the thermostat. There's nothing really sensing it except for maybe that small flap in the air cleaner to channel some warm air into the air cleaner. But beyond that, they were guessing, and when they did guess, it was pretty rich.
Yeah, and that's what, you know, I joked earlier, you know, I referred to a carburetor as a controlled fuel leak, and it's really nothing more than that. You know, you're using the carburetor to, you know, it's pulling fuel through vacuum and stuff like that, and it's not like, you know, you have a Holley double pumper where, you know, that's all mechanical, so as much fuel as that thing's flowing is it's all with your foot, versus like our Quadrajet on our El Camino where it uses metering rods and vacuum and all sorts of other things to work and kind of work right. But again, it's still just a guess. It's, it doesn't actually have, O2 sensors or anything like that. So whatever that carburetor was set to, that's how much fuel it's going to give it regardless.
And on top of that, you really look at today's modern engines as far as what they're able to run stoichiometrically. I mean, I've seen 14.7, I've seen 17.2. It all depends on what that engine feels safe running, and it looks at the NOx sensor, it looks at the misfire monitors, and it can go pretty lean if it wanted to. For example, moving down the freeway, with a light load on the engine, it can run pretty lean, but that carbon problem with the direct fuel injection and the fuel not washing off the back of the valves, our El Camino didn't have that problem.
No, that was not something that had exists in its book.
So do we have that footage of the waveform? Okay, we'll post that later on. But with that repair that we eventually had it done, we timed up that, and I think once everything was done, it was at 26 degrees.
Yeah, at 26, and that's like safe for a small block. You're right in that range from 26 to 30 to 32 is kind of where they like to live. Any more than that, the car will get hot. It won't want to start. You'll get a huge knock issue, and eventually, like I said, you'll burn the thing up. So too much timing can be detrimental and a really bad thing for some stuff. So, it's not like in a modern automobile where, it's variable timing all the time. So it's going to pull, depending on its load and how it's running, where you are in the throttle, kind of just, even what in gear selection and a lot of stuff, where it's going to want to be in a timing table versus with our small block, it's a set it and forget it. And it has, it just runs through a spark curve in the ignition box. You also have different, the distributor we took out was a mechanically advanced distributor. So it has springs and weights where at a certain RPM, the distributor flails out, and that's, it runs it up the timing curve, and that's it. You can even lock distributors out. So it's, say we set it at 26, we lock a distributor out, it's going to be 26 degrees of timing all the time. And then they also have vacuum can distributors, which, that uses vacuum from the engine to control the timing curve then. And that was kind of a, when that stuff came out, that was the latest and greatest in technology. It's not like getting in a timing table today and, looking at it in a car and seeing where, you have a whole table and a whole progression where timing is constantly adjusting itself and it's going to move. So leaps and bounds in technology, it's all to make the thing more efficient, with modern automobiles, it's making the most power possible out of the smallest package.
And you really think about that distributor system with the Advance. Okay, you had the springs, those could weaken up. Some of the weights could be, sticking to the part of the distributor itself, and that could really be affecting, the overall timing, the curve, to where on a modern engine with one of these, it's nothing but an input from the ECM. And that's just that one more little bit of slack in some of that older OBD0 stuff.
Yeah, and that's the thing, is like you have everything wears out. So, like I said, you see in some of like, my example I go to is like, in the late 70s Ford stuff, and like, you say in those 385 series small block or big blocks, it has a nylon, nylon teeth on the front of the timing gear. Well, that stuff eventually wears out, and, then you get some slack in the chain, and the distributor gear's worn, and, the distributor has, kind of gotten beat up. Well, then you have a big timing variance on some of that stuff. So, all these parts get worn a little, and it, makes for a lot of play, and it doesn't, it'll eventually start to run poorer and poorer. So that's something you need, if you're restoring an old automobile, that's something important, or just rebuilding a small block to rejuvenate it, that's something important to pay attention to, how your cam gears wore, how the distributor drive's worn, what the overall health of the distributor is, your timing set, because all that makes a difference in how it's going to run.
Bring up a good point. Recently, dealing with a Ford 5.4, 3-valve, and dealing with the camshaft phasers. And it's almost the exact same situation you're describing, because there was issues with, number one, oil pressure. Oil pressure making it through the camshaft, which was a little obstructed, and then to the solenoid, and then to the variable valve timing actuator. And, the truck had probably about 140,000 miles on it, but it didn't have enough oil pressure to properly actuate the actuator for the variable valve timing, and it would flip over and it would cause noise at startup. And that's exactly what happened with some of the older vehicles. Is they lost pressure, the distributor would wear out, the bronze bushing would wear out, but now we're seeing it with variable valve timing.
Yeah, and that's the thing is with some of these some of this modern stuff, it's with VVT and all that, and I was in a newer 5-liter, a Gen 1 Coyote Ford, just a few weeks ago, and that's the issue this thing had, is it snapped, it snapped the timing chain. And just looking the overall condition of the engine didn't look that horrible, but to look at the cam phasers and all that stuff all needed, it's not that old of an engine and it needed replaced, but all this stuff got a little worn out and, decreased the health in the engine, and it was kind of, that's what put the nails in the coffin for that thing. And you get all these little parts wear, and you get an oil pressure issue or something like that. It's a compounding issue until you have a major failure, then you have some problems.
The funny thing I think about that Ford 5.4 that I was dealing with, it was an issue where the guy didn't change his oil enough. I think he said he changed it. I changed it every 7,000 miles. But the drive and loop that he was on, he should be changing it every 5,000 miles, and that affected the life of the timing chain, the phaser, and other components on the engine.
Yeah, and overall vehicle, keeping your vehicle in good health and overall vehicle maintenance is very important, because, it's not just, if you want the thing to not just be a good time, you want it to last a long time. So that's very, very important. So keeping up on your maintenance and just, general stuff is very, very important. So, between changing your oil, making sure you put plugs in it all the time, air filter, cleaning your MAF sensor and your just multiple things, replacing O2 sensors when they need replaced is very, very important.
This is a great question we just got in, and I kind of like this. It was just handed to us by our producer here. This is on a coil on-plug system. Would each coil have 8 times longer dwell time to build a spark, firing 1 time per revolution, versus an old school coil that fires 8 times per revolution of a V8 engine? Dwell. That's what you use to set up points, but it's still valid because dwell is technically still there, except it's a switching on a transistor.
So in a coil, that's a really good question, because you're only going to be able to charge, it does essentially have a longer charge time, but that coil, depending on how the winding, the primary and secondary winding is, it's only going to charge, you only can charge it so, it's only going to charge to a certain amount. So if you look at it in the old coil is really, really efficient because it's charging 8 times as fast as, your single little coil.
And you really think about, when it's firing, to think about the life of the coil. If coil's only firing once per revolution for a given engine, it's probably going to last a lot longer. So it's going to stay inside the emission specs longer, and you don't have to worry about the firing of the plug, other sensors that can go bad. That was the big issue why OBD 1 or 2 came out, was just making sure that the vehicle stays within emission specifications during the first 30 to 40,000 miles.
Yeah, and even with some of that early OBD1 stuff, those, if you even look at the odometers in those cars, most of them only go up to 100,000 miles because they planned the vehicle only lasting that long, versus what we have nowadays, where you see it's not crazy to see a vehicle with 250, 300, 400,000 miles on it. So that's what, with the early OBD1 and even into OBD2 A and B, it's, that was the whole point, is to keep the thing in emission standards, because you want it to run, at its peak all the time, and you don't want it to be, unnecessary pollution, clogging up catalytic converters, really gummy EGRs, and running at its, in bad condition.
I'm just looking at this unit right here, and you have different things for a 4-cylinder, 6-cylinder, 8, when you're determining the dwell on the engine itself, and you're setting up a set of points. But it's also a diagnostic angle, because that's the number of degrees that you're dealing with when it's open and charging the coil. So that was a good question. That's a good challenge. I like Dwell as far as a diagnostic angle, even though the typical scan tool will never display it that way. Usually, if you're looking at a scan tool, the data PIDs you're looking at is advance, misfires on a scan tool to make sure that it's operating properly.
Yeah, and most technicians nowadays aren't going to see a set of points, roll into their shop or anything. Like I said, there's any of us that have ever drove vehicles that had points, there was always that, you always had that little piece of sandpaper in your glove box for when the points, the points got welded together and a small screwdriver, so you're taking your distributor cap off, sanding your points, putting them back in, and, trying to make the things last a little longer. But like Andrew was saying with setting Dwell, that was the way, and you were just trying to get the points to stay open long as possible so the coil would charge and you'd get a nice big blue spark.
Got a great question in here. This comes from a technician. He's wondering, using a leak down gauge, how do you determine if it's an exhaust valve or an intake valve?
So there's going to be, when you roll the thing over to whatever cylinder you're checking, you're going to want to run the piston up. So, and if you have a sticky intake or exhaust valve, you're gonna hear it. So you'll either hear it coming through the exhaust and or leaking through the intake. So you'll get like it depends on the leak down as well, because you're going to have some by the ring. So if you have a ring seating issue, something like that, you're gonna see a small number. So like on an engine I recently did a leak down test on I had like a 5% leak down. So that's not like a big crazy number. That's the thing was in good health, but I was checking for a ring seating issue because it kind of just seemed like when I compression tested, the thing was low on compression. So what I ended up finding actually is the thing had a bent rod. And through a leak down, the leak down test told me that it had 2 good intake valves and that the rings were seated properly. So I needed to investigate into it further.
And it's funny, thinking back to that question, I've actually looked at a lot of different ways to detect on a leak down. And some of the detectors with a small piezoelectric microphone, you can insert that into the exhaust system and you can kind of hear the air escaping through the exhaust valve on some of those, or even through an intake you can hear that. Not that that's the final, but it can get you into the right cylinder, or if it's the intake or exhaust valve. And it's a small sensor that you can actually even use to look at the exhaust pulses coming out of the exhaust to determine if there's a misfire. And it's a non-invasive test, I like to call it that way, because we're humans and we like non-invasive tests. That you just put this hose into the back of the exhaust pipe to look at the different power pulses. And if there's a certain gap where a cylinder is missing, it can give you an idea if you do have a misfire. So we got another question here that was just handed to me. What's the difference between an oxygen sensor and an air-fuel ratio sensor? And, OBD1 had a lot of the first oxygen sensors, and the air-fuel ratio sensor we're seeing on a lot of modern vehicles. What's the difference between the two?
So with an O2 sensor is not quite as precise as an air-fuel ratio sensor. So it just kind of knows lean or rich. It's very crude. It it has a certain a parameter it operates in, and it's A or B. It's always lean rich. It's bouncing back and forth. With with an air-fuel ratio sensor, it's live. So you're not actually you're using that as a diagnostic, not as controlling a computer system. So it's going to say, at the current moment this is running, it's 13.1, it's 13.5, it's going to tell you what it is at the current moment, how lean or rich it is, and it's going to give you, I don't know, I'm looking for the proper term for,
millivolts or signal.
Yeah, your AR ratio.
Lambda is the term I've heard a couple different times. Stoichiometric. But yeah, it changes, and you really look at an air-fuel ratio sensor, where a normal oxygen sensor that you first saw in those 1980 GM and Toyota vehicles, they were only looking at probably this little bit amount of stoich, and they were seeing it bounce back and forth, to where if you have an air-fuel ratio sensor now, it's able to see inside that cylinder a whole lot better, and they're able to see it bounce back and forth, and then hopefully control it with spark and fuel and everything else. So it's kind of a neat way to really think about modern engines and oxygen sensors and air-fuel ratio sensors.
Yeah, but it's at the end of the day that an air-fuel ratio sensor is, it's way more precise than an oxygen sensor is. So it's more, you know, you see AR stuff and it's a lot of times you're putting air-fuel ratio on a vehicle where, you know, it's a performance-oriented thing. So, you know, you have a car, you build a drag car or something like that, and, you know, you're using that as a tuning aid.
And think about it on a modern vehicle, like a zero emissions vehicle or a partial low emissions vehicle. They're actually using that ability to sense that a lot more of stoichiometry to maybe add a little bit or take away a little bit of fuel so there's more oxygen in the exhaust gases to help run the converters and reduce some fuel and other issues and keep them going and light them off sooner. So it's an interesting emissions question.
Yeah, and that's the thing with, like, we talked about, you know, converters and stuff like that, and even some of our modern diesel vehicles with, you know, deep diesel particulate filters, you know, having, you know, the engine in good running health, so, you know, you don't get a bunch of excess fuel to clog up your converter or make the converter life shorter. Because that's the key is, you know, you're pushing this exhaust gas through a catalytic converter, and it's simply just a chemical reaction there, and it's pulling, you know, you're running over these precious metals through the, you know, a catalyst of sorts, and it's just pulling, you know, it's pulling certain things out of it to make the exhaust gas, you know, a lot friendlier for the environment. So those converters have a lifespan to them, and, you know, if you have a vehicle that's in poor running health, like it's, you know, the thing is rich all the time, you know, it's burning, you know, it's not burning all the fuel correctly, well, that converter is going to last a lot less time. So it's going to lead to a cost, you know, catalytic converters are full of precious metals and other sorts of, you know, hard, you know, unobtainium, as I like to call them. But it's a modern converter replacement's expensive. So, you know, making that converter last as long as possible is very important. And the last thing you want to do is have a plugged catalytic converter, because it's really going to affect how your vehicle is going to run, if the thing will run at all.
Interesting question here. Why would you run an ignition box on a vehicle that may not be modified that extensively?
So the big thing about us putting the multi-spark box on that is it's just it's a step into modern technology. So versus having with our coil setup with our old distributor and stuff like that, you have one, you know, just one solid blue spark. With that multi-spark ignition box, you have a whole bunch of, you know, but they're multiple sparks, little small guys that help you burn fuel. It's just going to make the thing run overall better. So in that, like, that car didn't have a rev, you know, it didn't have a rev limiter before or anything like that. So, you know, you not only added a safeguard, say the throttle gets stuck, you know, stuck open on that thing. Well, now you for sure know it's only going to rev to 5,600 RPMs. So it's just kind of a step into the future versus the old mechanical distributor and, you know, that was on the car before. So not that, you know, it affected you know, it was a good performance standpoint, but just as an overall daily driver and stuff like that, it makes an improvement in the vehicle.
Very interesting question. Keep them typing in the comments section, and we'll be answering them here. And this was a very great question and pointing out something that we may have missed. It says before trashing the Mallory distributor, we would pull the rotor off and test the free play at the main shaft and cam gear to ensure that mechanical advance weights are not giving a false wear indication. Good point.
That is a good point. At the time, you know, we were ripping parts off. We were, you know, we had that Summit distributor and ignition kit in mind. So, you know, checking those, it was, you know, in my eyes, it was bad before we pulled it out of the vehicle.
That was a nice distributor we put in there. It was fully billet.
Yeah, that's a really nice piece. So it's, you know, it's a full billet distributor, and it also uses, like, it's a really easy cap and rotor and stuff to get. So, you know, in the unfortunate circumstance you're out broke down on the road somewhere, you can walk into an auto parts store and get that cap. It came on a vehicle, you know, it came on a regular automobile at one point in time. And there's also a lot of aftermarket manufacturers. So, like, you know, an MSD cap and rotor would fit right on that thing with a, you know, seeing as you got one with the proper part number.
You know, and that was an HEI distributor, General Motors, and that was probably, HEI came out 73, I want to say?
Yeah, it's somewhere around there. It's, you know, the step when HEI stuff came out, that was a huge step in direction because, you know, I have everything I have is all contained right in the distributor. You know, you don't have a coil on the firewall or, you know, a pickup in the body. It's all in one shebang. So it's a distributor and wires and that's it. And GM really simplified that, and that was a huge. People still buy brand new HEI distributors today and run them. It's a really great proven system. Heck, there's people like Davis Ignition that even make HEI distributors for anything you can think of, from a big, you know, a big block Ford all the way down to a little 4-cylinder Volkswagen. So it's that's HEI is, you know, it's tried and true and it's here to stay.
Another great. This is the same guy about the rotor and the free play of the main shaft. This is, you know, let's not forget the worn nylon bushings on the distributor point plates of some Ford V8s from the 1960s through 1974, allowing dwell and timing variations of 10 to 15 degrees, starting around 40 to 50K miles.
So, and that's a huge number. And those nylon bushings, like I said, once they get a little bit of oil and gum, and like I said, you get a little oil up through the distributor and the running, like that eats that, you know, those old plastics and stuff up. So you know, they wore really well on their own, but you know, you throw some contamination in there and then they really start to wear. And a 15 degree timing, you know, window is huge. That's, you know, you could get that thing, it could, you know, end up somewhere around like 40-ish degrees of timing, and that's going to be no good. Like I said, if it'll run, you know, it's not going to run very long because that's going to cause a huge detonation issue, and it's going to be a bad day for that engine. So, you know, as me and Andrew are sitting here talking about, that's something also important to cover is, you know, we're talking about advancing and retarding the distributor, and basically, you know, if you advance the distributor too much, like I said, you start to get a detonation issue. So the thing is, you know, it's firing way before the pistons reached where it needs to be, or with, you know, with a retarding issue, the thing is firing way later than it needs to be. So there's a certain sweet spot. Like I said, we set that small block in the El Camino up right around 26 degrees. So that's where the small block's like, and that's a general rule of thumb. You know, anywhere between, you know, 26 and 30. Almost everything will run, and it'll run well at that.
Yeah, you bring up a good point about, you know, that it's the flame front. If it's advanced or retarding the timing, you're worried about when the flame front starts and starts to propagate and push down the piston. That's true no matter if it's carbureted, updraft, downdraft, side draft, or if it's direct or port injected. If you don't have that fuel igniting at the right time, then there's going to be big issues.
Yeah, and that's an important thing to think about. You know, with the spark and how everything's working, you know, on your power stroke and your ignition into your power stroke on your engine. You know, the piston's coming. You know, you throw a spark into the cylinder, and it's not an instantaneous, you know, explosion. You know, you have a certain time when the piston's coming to the top of the cylinder and the rod is changing direction, you know, that's actually referred to as piston dwell time. So the whole time the piston is coming up and the rod is switching direction, you know, that's a full fuel burn. So it's important that, you know, you think about it in that, oh, you know, I have this explosion, the spark plug went off. It's not instantaneous. You know, it might be milliseconds that this is going on, but it's doing it, you know, thousands of times, you know, running in a minute.
A question came in with that ignition box. What did the waveform look like? We did have a clip of it, and what it was, you had the secondary fire, and then you had 2 to 3 more firings of the spark plug to help clean up things inside the cylinder.
Yeah, with multi-spark ignition, like I said, you have a big fat initial spark, and then you have about 3 or 4 smaller delayed sparks to help continue the burn, because the more times you can get a spark and a discharge, the more fuel you're going to burn. And that's the other thing is, you know, when you get into high performance engines and stuff, you know, you're using, you know, higher octane fuels, not your just regular 87 you get out of the pump. Multi-spark really makes a big difference, because the higher you go in octane in fuel, the more, you know, it's a slower burn time. So the slower burn, the more that fuel you can burn, the more power it's going to make. So, you know, if you get into something, you know, if you have something that has a good healthy compression ratio, you know, right around about 10.5 to 1 is where it starts, all the way up into big numbers. you want to run a higher octane fuel, or also you said you get in a detonation issue and you're going to melt a hole through a piston, or worse, you could just, melt the whole thing down. So, with multi-spark, it makes a big difference in, complete fuel burn and making good power.
Question just came in. E85. How does that change spark timing? And I guess this even applies to some of the flex fuel vehicles and even some of the modified vehicles.
So E85 is, there's a lot of guys that make big power on it, but it takes a lot more. Alcohol takes, in carbureted days, I don't own anything that runs on an E85, but, I've had some stuff that's ran on alcohol, and the big thing about that is, versus gasoline to alcohol, you double your jet size. So it takes twice as much fuel, but it's going to make a lot more power. So, and alcohol also burns cool, so you're going to want to, if the thing's running hot, you just give it more fuel, and it makes more power, and it runs better. So with that also, though, you need more spark. So if you're throwing more fuel in it, there's going to be more fuel, more air. You need, you need more spark to burn the deal. So you're going to have a lot less, the timing curve is going to be a lot less than gasoline is. So you're going to take a little bit of timing out of it as the more fuel you add, but it's going to burn, like I said, you're going to make more power with alcohol.
And the E85 question too on a production vehicle, flex fuel, it's so important because it's actually on some vehicles they actually have a sensor that it runs the E85 through, and some performance vehicles are the same way, to where it measures basically the specific gravity of the fuel as it passes through. But it's also measuring how the fuel burns and what's going on with it using the oxygen sensors, NOx sensors, the misfire sensors to determine, okay, what type of fuel is in there. And typically with a scan tool, you can look on here and it will actually detect if it's E85 or just normal gasoline. Some will, just say, 87 octane. But you can look on your scan tool to see what's in the tank, which is, I think, kind of cool on some of these flex fuel vehicles.
Yeah, so the GM flex fuel sensor is tried and true. There's actually tons of aftermarket companies that use the flex fuel sensor on all sorts of stuff. So with that, there's even guys, making aftermarket kits to fit that. Say if you have a BMW or something like that, or some into the Ford, the Ford Focus RSs are really popular vehicles, and they retrofit these GM fuel flex sensors to that stuff, because the thing about E85 is it's not necessarily always 85%, 85% gasoline with 15% alcohol. So, the ratio is always varying, and the vehicle needs to know that, because if it doesn't, like I said, you could have some kind of catastrophic meltdown issue and, ultimately a failure. So having live timing of the, seeing what your alcohol content in your fuel is very, very important.
Yeah, the E85 question, man, it's definitely fuel, spark, and it's able to adjust it. I mean, that's something that our El Camino couldn't do.
Yeah, no, like the El Caminos, set it and forget it. It's always going to be the same amount of timing. So with, with this modern stuff that's all computer controlled, you constantly have varying to make it, like I said, give you the best, the best ability to burn and the best timing for the moment.
Okay, we're coming down to our last 5 minutes, so we've got a couple more questions here. And this one was very interesting. How would you be able to detect if the camshaft was worn out? Would that be possible for our normal checks?
So you could do that. That's a with hydraulic lifters and stuff like that. That's kind of hard to really check out. You can see if your timing set on the front. It's more of you have to pull the camshaft out of it for a real diagnosis. But if you had an issue where, if the thing had solid lifters in it and, you ran, they give you the ability, there are tools out on the market to where you can like bolt a dial indicator to a rocker bridge and check to see what, if you had your cam card, what the cam lift was supposed to be, you could sit there and check it like that. But generally to, inspect a camshaft for wear and stuff like that, unless it's a totally, the lobe is just gone and it's not lifting anymore, and you have a sloppy rocker and a push rod that moves. If the push rod was laying under the oil, under your valve cover, you have an issue.
Yeah. Oh God, yeah. Okay, couple comments here I'm going to share. Why don't you LS swap that car by Eric? The couple of comments like that we should LS swap this car.
So I am all, I'm a big GM guy. I'm all advocate for the LS swap, but it's nothing beats a traditional, your 350, 400 small block. If there's no, it's cool to bring one of these vehicles into the modern era with fuel injection and, the LS reliability and, there's guys making crazy power out of these things that, they're ripping them out of a junkyard, they're putting, a cam in it and putting it back together and making great power. But still, dollar per horsepower, the small block reigns supreme. There's so many new and used small block parts out there. Like you can build a really aggressive 400-500 horsepower small block for not that expensive. So, but the LS swap is cool to bring into the modern era. Like I said, you can get a 4L60 or a 4L80, then you get overdrive, which is cool.
Yeah.
But for the moment, it's the El Camino to start up and drive, with the turbo 350 and a Smalley 350. That's a hard thing to beat.
It's like going back in time. There's some sweetness to a 3-speed.
Yeah, there's nothing that small block sound and how they drive, and it's just I don't know. That's what I said. I drive an LS powered truck every day, but I enjoy getting a small block powered car out.
This is a question from one of, this is, what diagnostic tools would you recommend for a technician just sorting out where he should spend his money? Is it more on the leak down gauges and compression gauges versus a scan tool?
So, if it really depends where that's kind of a more open-ended question. It depends where you're going. If you're, you're just out of, you're not working in a lube tech shop and you've just gotten to a dealership and stuff like that, a scan tool is going to be something you're going to use way more than, a leak down tester and a compression tester and all that. But if, say you're a home mechanic and you're just working on some stuff and you're primarily working on your small block or big block powered truck, that stuff's going to get you a lot farther than a scan tool will. So, and there's also affordable, you don't have to walk onto a tool truck and spend $5 on a scan tool either. There's some really affordable options out there, and it's worth to do some shopping and seeing, all tools don't have to be expensive. There's some really great economy options to make your dollar go far. So you don't have to spend, walk onto the truck and, sell your firstborn and, spend all the money. Like, you can get some really great tools at a really great price for just, like I said, getting on the internet, doing some shopping. It always doesn't have to be something with a name brand on that, and that's important to know. So, you don't, either getting like a scanner from a great company, like said, you have Autel is like one of my personal favorites. I use the snot out of their stuff. Another great for diagnostic tools is, Lang Tools. They make tools for a bunch of big manufacturers, and it's, a lot of stuff they private label. So that's important to know.
My best advice, if you look at a scan tool, make sure you're looking at the OBD2 coverage. That's the generic coverage to look at misfire monitors, EVAPs, make sure monitors are completing continuous and non-continuous, and that is truly what makes a scan tool valuable. And if you understand what's going on, that can make you even more valuable. So we're going to wrap it up here. We're at the 1 hour mark. Thank you for everybody participating. Justin, thank you for stopping by here.
Yeah, always a pleasure.
This is a great conversation, especially for the Underhood audience who their main business is diagnostic labor. And I'd like to thank our audience and you and Summit Racing for sponsoring this. This has been a lot of fun.